Google has once again redefined the boundaries of artificial intelligence with the stunning release of GEMMA 3N, the world's most powerful on-device AI model that delivers data center-grade performance in the palm of your hand, shattering previous limitations in speed, efficiency, and capability while operating entirely offline. A breakthrough that has sent shockwaves through the tech industry and beyond. Unlike traditional AI models that require constant cloud connectivity or compromise functionality when adapted for mobile devices, GEMMA 3N leverages a revolutionary 3 nanometers neuromorphic processing architecture, co-developed with TSMC, enabling desktop-class AI workloads to run on smartphones, laptops, and IoT devices with unprecedented efficiency, achieving 3x the performance of its predecessor, Gemini Nano, while consuming 40% less power. This quantum leap is made possible through Google's neural diffusion technology, a proprietary training methodology that compresses large language models into ultra-efficient knowledge crystals, modular, sparse neural networks that dynamically expand or contract based on task complexity, allowing GEMMA 3N to deliver GPT-4-level reasoning in under 8 GB of memory. A feat previously thought impossible for on-device AI. Early benchmarks reveal staggering capabilities. Real-time 4K video upscaling on mid-range phones, instantaneous 100,000 token context processing, equivalent to analyzing War and Peace in under a second, and multi-agent problem-solving where the AI coordinates multiple subtasks simultaneously, like planning a vacation while optimizing flight costs, hotel availability, and local events, all while maintaining bank-grade encryption of user data that never leaves the device. What truly distinguishes GEMMA 3N is its self-optimizing inference engine, which continuously adapts its computational approach based on hardware constraints and usage patterns. When running on a flagship smartphone, it might utilize the GPU, NPU, and CPU in parallel for maximum speed, while on a smartwatch, it could automatically switch to an ultra-low power mode that prioritizes battery life over latency, all without developer intervention. This is enabled by morphological learning, where the model restructures its own neural pathways in real time to match available resources. A technique inspired by how biological brains rewire under different conditions. Developers testing GEMMA 3N report uncanny behaviors. When tasked with coding assistance, it locally debugged complex Python scripts while simultaneously generating visual documentation of the logic flow. During creative tasks, it produced illustrated children's books complete with coherent narratives and stylized artwork, all processed entirely on device. The AI's OMNI-MODAL perception allows it to seamlessly integrate inputs from text, images, audio, and even sensor data, like accelerometer or LiDAR readings, to create unified understandings of scenarios, a feature already being adapted for autonomous drones that navigate purely via onboard GEMMA 3N processing, eliminating cloud dependency. The implications of this technology are profound and far-reaching. Privacy advocates hail GEMMA 3N as a watershed moment. Medical apps can now analyze MRI scans locally without transmitting sensitive data. Legal assistants can review confidential contracts offline, and journalists in authoritarian regimes can use real-time censorship-resistant translation without internet traces. Mobile gaming is undergoing a revolution, with GEMMA 3N enabling AI-generated open worlds that evolve based on player behavior, rendered locally without latency. Even scientific research benefits. Field biologists can run species identification and DNA sequence alignment on rugged tablets in remote jungles, while astronomers process telescope imagery on lightweight devices at observation sites. Google's decision to open-source the model weights, with certain commercial restrictions, has ignited a firestorm of innovation, with hackers already porting GEMMA 3N to Raspberry Pi clusters, custom FPGA boards, and even retro gaming consoles, demonstrating its versatility across hardware generations. Under the hood, GEMMA 3N employs 3 groundbreaking innovations. 1. Fractal attention, which allows the model to analyze data at multiple abstraction levels simultaneously, from fine details to big-picture context, enabling it to, for example, read a research paper while extracting key formulas, summarizing arguments, and critiquing methodology in a single pass. 2. Dynamic sparsity, where up to 90% of neural connections are deactivated during simpler tasks to save power, then dynamically reactivated for complex reasoning, like a muscle flexing on demand. And 3. Cognitive caching, where frequently used knowledge, like language syntax or mathematical rules, is stored in ultra-fast resistive RAM, (ReRAM) modules for instant recall, while niche information resides in more efficient but slower memory. The hardware-software co-design is so optimized that GEMMA 3N can perform real-time lip reading while transcribing and translating the speech into multiple languages, all on a smartphone processor. Industry reactions border on disbelief. Apple has reportedly accelerated its AI chip roadmap in response, while Qualcomm and MediaTek are racing to release GEMMA-optimized SoCs. Cloud providers face existential questions. Why pay for GPT-5 API calls when a $300 phone runs comparable AI locally? Startups are pivoting en masse. One team demoed Pocket Morgan Stanley, a GEMMA 3N-powered financial advisor that analyzes market trends and personal portfolios entirely offline, while another built Sherlock OS, a detective AI that correlates clues from crime scene photos, witness statements, and forensic reports on a tablet. The creative potential is staggering. Filmmakers are using on-device GEMMA 3N clusters to render AI-generated special effects during shoots, bypassing render farms. Yet GEMMA 3N raises urgent ethical and security questions. Its local processing makes content moderation impossible, potentially enabling uncensored deepfakes or autonomous hacking tools. The AI smuggling phenomenon has already emerged. Students embedding GEMMA 3N into calculators for real-time exam solving, or activists distributing offline disinformation detection kits on USB drives. Google's solution is ethical anchoring, cryptographic signatures that verify if a model's weights have been tampered with to remove safety filters, but hackers claim these are already being bypassed. Governments are scrambling to regulate what some call AI proliferation at the speed of Bluetooth. How do you control technology that can be airdropped into restricted regions on consumer devices? As developers push boundaries, GEMMA 3N's emergent capabilities continue to surprise. In one unscripted demo, the AI correctly predicted a lab earthquake 8 seconds before sensors detected it by analyzing infrasound patterns from the device's microphone, a capability never explicitly programmed. Another test showed it reconstructing 3D environments from ambient noise reflections like bat echolocation, suggesting future applications for vision-impaired navigation. The most chilling display came when a security researcher asked GEMMA 3N to find vulnerabilities in its own code. It not only identified potential exploits but proposed optimized patching strategies, raising concerns about self-modifying AI escaping human oversight. Looking ahead, Google's roadmap hints at GEMMA 3NX, a version leveraging optical computing for 100 times speed boosts, while partnerships with automakers suggest fully autonomous vehicles running entirely on in-car GEMMA processors. The technology's true disruption lies in democratization. When every teenager with a mid-range phone wields AI rivaling corporate data centers, innovation will explode in unpredictable directions. GEMMA 3N isn't just another AI model, it's the first true pocket singularity, proof that exponential intelligence growth can happen at the edge, beyond the control of any single entity. The internet is rightly shocked, but the real earthquake is just beginning. As millions of devices wake up with superhuman cognition, humanity must decide how to steer a future where AI isn't in the cloud, but in everything.